Good morning. Um, Myself, Dr. Sajid Subramanian, Associate Professor, Department of Biomedical Engineering, KIT Kalankar Karunanidhi Institute of Technology. I welcome you all. You are at a moment, correct moment for understanding what is signals and system. My motto is to deliver the lecture point which deals with the signals and system, which is useful for exam point of view also. I will brief the content of your signals and systems with the basic. So, what is signals? Anything that carries information in a life, in a day-to-day life, can be called as a signal. Signals constitute an important part of our daily life. So, what are the examples which is available in a day-to-day life? Like our voice signals, like our video signals, like our audio signals. So, we may classify different types of signals actually. The signal is defined as a single valued function of one or more independent variables. The independent variable may be mentioned as a time or frequency content. So we can call that as a single valued functions of one or more independent variables. A signal also defined as a physical quantity that varies with the time or it may be varies with the space or any other independent variable. It may be represented by a time domain or frequency domain. Okay, for example, if I'm going to take a human speech, we call it as a speech processing, or we can call that another example as a video processing signals. So that are all physical signals. If we are going to take electrical current and voltages, that parameters we can call it as the currents or voltage signals. A signal can be a function of one or more independent variables. So that independent variables, as already I mentioned, it may be of time or it may be of temperature, position, pressure, distance, etc. So it may be of any type of independent variables. So if a signal depends only one independent variable, it is called as a one-dimensional signal. And if a signal, if it depends upon two independent variable, we can call it as a two-dimensional signals. Or if suppose I'm going to take that signal is dependent upon a two or three variable, three independent variable, we can call it as a multi-variables or multi-dimensional signals. Okay. So basically, a function of one or more variables, as I already informed, that convey information on the nature of a physical phenomena, we can call it as a signal. So, what is signals? In terms of a biomedical application, heartbeat, blood pressure, temperature, vibration, these are all examples of what? Our signal. If suppose I'm going to deal with the bioanalytical process or bioprocessing system, I need a heartbeat rate. So that is one type of a signal, biosignal. We can call it a biosignal processing. So one dimensional and two dimensional, or it may be a multi-dimensional signals. Then system. What is system? So previously, I defined a signal. That signal incorporated through the system so that the system will give the output. So the system is the intermediate parameter or that is a element which is present in between the signal, that is the input and output side. So it's an operator that manipulates one or more signals to accomplish a function which is called as a system. So we simply defined a number of components which can be grouped together to perform a specific task by means of accepting the input signal so that it delivers the output signal. We can call that as a system. So the commonly encountered systems or examples of a systems we can call it as a speaker, one of the systems, audio speaker, one of the system. So aircraft landing systems, or another thing, a television is one of the mobile phone, vehicle, car, bike. These are all systems. By means of giving some input that is going to manipulate it, so we are getting the output. Okay, so this is the systems. Under the systems, it can be classified as a CT and DT. Then what is CT and DT? Which is nothing but continuous time and discrete time signals. In the figure A, it is mentioned as a continuous signal. That means it is having its own value at all instant of time. So we simply call this is the variable, that is X variable is T and Y variable is X of T. If such a things are present, we can call that as a continuous time. In other words, if we are going to take a figure B, this is a discrete time series. In this, in between the value of 0 and 1, or if I'm going to mention the n in x-axis, in n is if n is equal to 0, that is the element. If n is equal to 1, that is a signal. Okay, so in between there is no signal. So at a discrete point of time or instant only, the signals having its own strength. So we can call it as a discrete time signal. So basically, signals may be classified as continuous time signals and discrete time signals. Then how the signals are represented? So the signals may be represented by means of a graphical representation, functional representation, tabular representation, and sequential representation. So what these four phenomena will defines, that means a graphical representation. Here you can see the graph which illustrate the position of a signal at various time intervals. In this example, if you take n is, if this is x-axis n and this is the y-axis x of n. If I'm going to take n is equal to 0, in that the value is nothing but 0. If I'm going to take n is equal to 1, the value is nothing but 3. If I'm going to take n equal to 2, the value is 1. So that like that I can able to mention the value of signals at every instant of time. Okay, so this will represent what is nothing but consider. So x of t is equal to what? X of minus 2 is equal to minus 3, x of minus 1 is equal to 2, x of 0 is equal to 0, x of 1 is equal to 3, x of 2 is equal to 1, x of 3 is equal to 2. That means it illustrates the position of a signal. So then what is functional representation? That means we can simply put the strength of the signal in terms of a function. That means for a same example, that means for n is equal to minus 3, the value that is that minus 3 belongs to the value of n is equal to minus 2. So like that I am going to mention if for n is equal to minus 2, the value is minus 3. Similarly, for n is equal to minus 1, the value is 2. Like that, I can able to mention for n is equal to minus 1, the function is 2. So like that, I can able to mention all the signals in terms of a functional element. This is one example. Another example, if you take 2 power n, for all n is greater than or equal to 0 and 0 for all other value of n is less than 0. So this is nothing but x of. That means if n is equal to 0, the value is 1 because 2 power 0 is equal to 1. If I'm going to put n is equal to 1, the x of n is equal to 2. I can able to write in terms of functional elements. That is also possible. So tabular representation, that is nothing but here I can simply write in terms of a function. Here in this we can simply in terms of a tabular element. So that means this is of 0 correspond to 0, n is equal to 0, 3 represent 2, n is equal to 1. Similarly, 2 represent to minus 1 and minus 3 represent to minus 2. So for every instant of time, I can mention x of n in terms of a tabular form. So sequential from within a parenthesis, I can able to write and I can able to mention the arrow mark. This arrow mark illustrate where the origin belongs to. In this point, 0 is nothing but our point of illustration, which is nothing but the origin. This is nothing but the right hand side and left hand side sequences also there. 3, 1, 2. This is nothing but the positive sequences and this is nothing but the negative sequences. So this is nothing but a double-sided signal. We can call this or these double-sided signals with respect to origin O. Another example is nothing but here also it is possible 0 and here it is nothing but positive sided sequencer. This is the negative sided sequence. The arrow mark. So the arrow mark represent if n is equal to 0 term. Okay. So we can represent A signal in terms of a graphical representation, functional representation, tabular representation, sequential representation. This is very, very basics how to represent a signal. And what are all elementary signals? Normally, the signals can be classified as a unit step function, unit ramp function, unit parabolic function, unit impulse function, sinusoidal function, real exponential function, complex exponential function, like that. That means we can write a step, ramp, parabola, impulse, sine wave, exponential, real exponential, and complex exponential. This real and complex, which is nothing but real exponent, that is e power x, which is nothing but a real exponential function. If I'm going to write e power I theta, which is nothing but a complex exponential function, that is also there in terms of a signal. So for step function, you simply here. So this is a u of t. I will show that diagram here. There is a figure. So this is a graphical form of a signal. You just see here is a unit step function. In this function, what happened? This is the element that t belongs to x-axis and u of t is y-axis. Okay. So this is t, there's an independent variable. U is nothing but depending with this independent variable t. Units, that is, this is nothing but t equal to 0. At t equal to 0, u of t is equal to 1. So I mentioned this as the unit step. This is the value is 1. Since the value is 1, I can mention this is the unit step function. After all the value, once it rises to 1, the value retains its magnitude. Okay, and here you can simply see here from this point, origin is now shifted to t equal to a. Shifted sequences. It is nothing but a shifted sequences. Okay, or we can simply call it a delayed unit step function. It is going to delay, the function is delayed by the value of a. So this discrete time unit step sequences is defined as, how to define the sequences for all n is greater than or equal to 0. U of n value is nothing but what? This is 1. For all other value, the value is nothing but 0. So the positive sequences, it is 1, and negative sequences, it becomes 0. For similarly, for shifted version, it was shifted by the value of a. So when that is a t is greater than a, the value is 1. If it is less than a, the value is 0. Okay. So this is n minus k. K is nothing but here in this figure, this is a graphical representation. K is nothing but a. So 1 and 0 for all n is greater or equal to k, and for n is less than k. And discrete. We already mentioned here, this is the discrete time function. This is the continuous type. This is the continuous because I already mentioned continuous signal having all its magnitude over the period of time, whereas the discrete having a discrete quantity of signal or its amplitude only at a discrete instant of time. Okay. So here you can see here, this is also 1. The magnitude is 1. You can simply call it as a unit step function. And this was shifted by the element of k or n minus k. We can call it as n minus k. So just to see here, it was shifted by the value of k. After the k, all the signal strength is retained at the value of 1. This is nothing but a discrete type unit step and shifted unit step function. And if you see unit ramp function, how it is to be mentioned, just to see here, this is the ramp function. This is the ramp function. In this ramp function, x-axis can, or normally we put the x-axis is time, the independent variable, and y-axis is r of t. Just to see the slope is always 1. This is the first figure, the slope is 1. In the second figure, what happened is also shifted by the value of a. This is shifted. The ramp signal was shifted by the magnitude of a. That is t minus a. We can call it t minus a. So how it is to be represented? R of t is equal to t. That means if you see here, R of t is equal to t means if you put t equal to 0, the value of R of t is equal to 0. If you put t equal to 1, the value R of t is equal to 1. R of 4 is equal to what? That is a t equal to 4, R of 4 is equal to 4. So like that, the value is t for all t is greater than or equal to 0. And if it is 0 for all t is less than 0. Okay. So in terms of, I already mentioned, we are having a graphical form, a tabular form, sequential form and functional form. Okay. So here also we can put like this. R of t is equal to what? The value is t into u, because u of t is nothing but 1. The value of u of t is 1. I already mentioned here, it is u of t is 1, unit step sequence. Wherever you are seeing u of t element, that is a step, belongs to step. Wherever you are seeing r of t, that belongs to ramp. By default, it may mentioned as a unit ramp and a unit step function like that. Okay. So the unit ramp function has a unit slope like that. Here the slope is what? 1. So it is having the slope of 1. It is a signal whose amplitude varies linearly with respect to a independent variable. So how we define R of t is equal to integral of u of t. That means what? The ramp signal is the integration of the step signal, unit step signal. We can also define like that. So that means a unit step signal, if we integrated the unit step signal, it tends to a ramp signal. Keep in mind, this is very important. If you are integrating the step signal, we are getting a ramp signal. Okay. So integration of u of t is nothing but r of t. So that is nothing but what? Integration of t is equal to t. Because already u of t is 1. The unit step is 1. So what we are getting, if you integrate 1, we are getting t. So r of t is nothing but t. Okay. Similarly, if I need a u of t, by providing r of t alone, if we differentiate, we are getting u of t. So the reverse also possible. So keep in mind, if integrate a unit step, it rises to ramp signal. If it differentiated a ramp signal, we are getting step signal. Okay. So this is the delayed sequences by the element of t minus e. Okay, this is also possible. So here the discrete time, how it is to be represented. This is the same n. That is, this is the element. This is the element unit ramp sequences. In x-axis, we can represent the n, and y-axis r of n. So in this, you just see here, r that is a ramp is shifted by the element of 2. Here you just see here, this is a n is equal to 0. It is 1. It is 2, 3, 4. For n is equal to 0, it is 0. Similarly, for n equal to 1, the value is r of 1 is 1. For n equal to 2, r of n is equal to 2. Okay. Now, I'm going to shift by the value of 2. So, what happened? This element is shifted to 3. This element, that is a n equal to 1. That is a, now, this was shifted by the value of 2. Now, it is going to shifted here. From 3, we are getting the element. Now, 3 is the starting position. R of n minus 2 is nothing but what? 3 belongs to the origin of the element. We can write like that. There is a we can shift the sequences by the 2 or of n minus 2. That means shifted by the value of plus 2. Shifted by the value of 2. If it is r of n plus 2, we can shift it into the negative side. So now it is shifted in terms of a positive sequences. So this is the starting minus 3, minus 2, minus 1, minus 0. Now minus 3 is shifted to minus 1 actually. So here it is minus 1. So minus 1, 0. So what happened? They shifted by the value of plus 2. So minus 3, now it is correspond to 2. Minus 3 is correspond to 2. That is now from 0, it is shifted to 2 like that. Here also, this is the starting point. So if I'm going to write in terms of a parenthesis, minus 3 is 0, 0, 0, 0. And here 1, 2, 3, 4. Now this is nothing but minus 3 is shifted to a minus 1. So this is also possible. So unit parabolic function. The function of unit parabola. This is the continuous time unit parabolic function, also called as a unit accelerating signal. Keep in mind, this is an accelerating signal. Starts at t equal to 0. T equal to 0. The function is t square by 2. So just to see here, this is the parabola. This is the parabola. This is the parabola. Here also we can able to shift by the value of a. By the value of a. You see here, the function is t square by 2 for t is greater than or equal to 0. This is for t is greater than or equal to 0. What happened? The value is t square by 2. And if it is 0, t is less than 0. So p of t. Or we can simply call as p of t is nothing but t square by 2 into u of t. So the shifted version also, that is instead of a t alone, we can put t minus a. All other remains the same. Okay. If you are, whenever you are seeing this is having some lagging or leading parameters, we can tell that this is a shifted sequences. So this is shifted sequences. Okay. So the unit parabola function can be obtained by integration of unit ramp function. What is unit ramp function? This is nothing but t. Now it is t square by 2. So the parabola, which is nothing but the integration of ramp, which will gives the parabolic function. So keep in mind. So step function, if you are going to integrate the step function, we are getting the ramp function. If I am going to integrate the ramp function, we are getting the parabolic function. So if I'm going to differentiate this parabola, we are getting the ramp function. So like that. So the ramp function is the derivatives of parabolic function, and step function is double derivatives of parabolic. We can say this also like this. So this is also possible. So now in terms of discrete, instead of t, we put n. Instead of t, we are putting n. Nothing to be changes here. Because n is nothing but instant of time. So instead of t, we are substituting n. So this is the discrete type sequences having parabola at different instances. And this is the shifted sequences by the value of 3. Here, just to see here, the starting point -3, -2. Now it is shifted to -1. Okay. P of n minus 3 also possible. It is shifted here. It is shifted. It's a 3, shifted by 3. So what happened? 1, 2, 3. 1, 2, 3. -3, now it is 0. Okay, from 0 onwards, we are getting the signal. So next one is a impulse function. It's the most important function in the signal analysis. This is the short duration pulses. We can call this as a direct delta functions, which is always mentioned by del of t. So integration of -infinity to +infinity del of t into dt is equal to 1. Okay. So del of t having the value of 0 for all t is not equal to 0. And it is 1 when t is equal to. This is short duration pulses. Just to see, this is a short duration. Only at the short duration of time, we are getting the signals. Okay. So this is the impulse function as 0 amplitude everywhere except at t is equal to 0. And t equal to 0, the amplitude is infinity. Yes, a short duration pulse. We can simply call if the bullet is rising from the piston, what happened? A short pulses, it is going to happen. We can call this as. This is the impulse functions. Okay. So I explained a step, ramp, parabola, and the impulse functions. So up to this, I conclude basic different types of signals. Next class, I'm going to explain in depth. Thank you for watching.